Hi everyone. I'm Aaron and I'm an applications engineer here at Epiq Solutions. Pretty excited what I'm going to show you, but just want to start out with a little history behind it. We've had a lot of conversations with users, researchers, integrators over the years who are curious about how our radios fit into open source digital signal processing workflows. I'm fairly new here, so I decided kick off a series of videos to show you, not just tell you how our tools work in real environments. And basically, why am I doing this? I just want to show that Epiq hardware integrates with commonly used tools like GNU Radio, which I will explain here in just a second as to what that is. Hopefully, answer some frequent customer and developer questions with working examples, and to demonstrate real world workflows or workflows that could be used real world for our signal collection, decoding, and analysis. A little bit about my setup. I've got a laptop here that's running a pre-installed GNU Radio 3.10 from source. I've also installed Epiq's libsidekiq SDK and kernel modules. I am using the Sidekiq NV100 as pictured here in a Thunderkiq housing, Thunderbolt attached to the laptop. So you can see got some really high-end specifications here, especially that 16-bit SDR, GPSDO on board with some great pre-select filtering, all in that common small form factor there that you see pictured. I'm going to go through some tabs here because I've mentioned a few of these things, but what is GNU Radio? If you're not familiar, it's a free and open source software development toolkit that provides signal processing blocks to implement software radios. What I think is significant about that is it provides you, the integrator, a way to interface quickly with new digital signal processing workflows in the GNU Radio framework, both in real world receive and transmit or even a simulation like environment. And you can see that GNU Radio is well supported and used in academia, government, hobbyist environments to support that research in real world radio systems. Along with the GNU Radio, I installed GR Sidekiq, which Epiq Solutions provides in their GitHub repository. That is an out-of-tree module that's going to allow GNU Radio to interface with the libsidekiq and control the NV100. And then last, because I figured with everything as far as drones, it would be of interest to show a digital signal processing workflow that is going to receive and decode the first person video from an analog drone transmitter in the 5 gigahertz range. That is another out of tree module that I have installed. Again, we're using the NV100 as the RF front end. You can read more about the other solutions that Epiq provides on epicsolutions.com. This is just one of many solutions here. I'm going to go through this. This should go fairly quick, and then we'll close it out with really a so what. So I'm in my GR NTSC RC directory here where I have some example flow graphs that were provided. I'm going to use the receive flow graph. And this receiver flow graph really only required a few changes. I changed the source and I added, thanks to the GR Sidekiq, I added the Sidekiq receive source and connected it to the quadrature demod, which goes into our low pass filter, the NTSC decoder, video stream converter, and then a video SDL sync, which will show us the video. All of this was provided by the out of tree module, so all that decoding and demodulation is happening under the hood. It's kind of obfuscated a little bit with this block workflow GNU Radio interface. I did change the frequency carrier to 5.9-ish gigahertz, up the sample rate to 20 meg. Of course, the NV100 can support far more than that, but I left it at 20 meg. The bandwidth is set to about half of that. What's going to happen here, I'm going to run this flow graph and we're going to real time decode the video that is flowing off of this drone. And so you're going to see me in real time. So let's go ahead and we're going to run this flow graph. So we're going to run this flow graph. The NV100 is loading its profiles, and it's going to come up here in just a few seconds, and we're going to see this real-time stream on the black screen right here. All right, there we go. So no kidding, that is real time. The NV100 is sitting over here, and there's a drone up on a shelf over there. And so, yep, you're basically seeing me in the office here in real time, of course, black and white. But that's all coming from that interface of the NV100 through the GNU Radio, through this out of tree module. And that's pretty impressive. I'm really surprised at the quality of the video there in the stream. So, of course, I could interfere here with the receive path probably, but you get the idea there. So I'm going to end this. And that just stops that flow graph that we were running. And basically, I'll just close it out with, hey, what's the so what? So again, I just wanted to show fairly plug and play Epiq's hardware being compatible with GNU Radio using our out of tree modules and kernel drivers. You can get set up pretty quickly with signal acquisition pipelines without being vendor locked or some sort of middleware. And so, yeah, I'm really impressed by the quality of the video received. And so, really, if you're trying to prove out a DSP, a digital signal process algorithm, test a classifier, or validate modulation types, you can get up and running and build it pretty fast with GNU Radio and Epiq hardware. I'll close out the video, and we'll be back with more videos hopefully in the near future. All right, thank you.